these two integrals have exponential functions in it. So let's do this because I want to bring up two important formula. So the first one, the blue one, the integrand x to the e plus e to the x, tell me which one is an exponential function. The answer is e to the x. So the base e is exponential function. The x raised to the e power is not an exponential function. All right. So first of all, we have to integrate the x to the e, right? By the way, e is approximately equals to 2.1. So the x to the e is just like x to the second power, x to the third power. You can use the simple power rule. So that is e to the, sorry, not e, x to the e plus 1, and then 1 divided by e plus 1, because e is just a constant value, is approximately equals to 2.71. So that's why you use the simple power rule. And then for the exponential function, the integral of e to the x is still e to the x. This is a very special case, and I want you to write this down right now. Okay, the integral of e to the x dx, don't worry about the upper limit or lower limit, is just e to the x. I want you to put this down on your notebook. Why? Because the derivative of e to the x is itself. That's why the integral, the antiderivative of e to the x is equals to itself. This is a very special case. For the e to the x, it doesn't matter how many times you differentiate that, you still have e to the x. For the integration, e to the x, it doesn't matter how many times you integrate the e to the x, you still have e to the x. So you have to put this down on your notebook. So back to our problem. X goes from 0 to 1. So we have right here, we plug in a 1, so 1 divided by e plus 1, and then that is 1 to the e plus 1, and then plus e to the 1, right? So that is the first plug-in. The second plug-in is minus 1 over e plus 1. We have 0 raised to the e plus 1, and then plus e raised to the 0 power. Okay. So what do we have in the first square bracket? E to the any power is just 1. So we have 1 divided by e plus 1. E to the first is just e. And then in the second square bracket, since we have a 0 in there, so the first term is just a 0. But e to the 0 power, this one, e to the 0 power is just equals to 1. Is that a plus 1 or minus 1? The answer is minus, because by fundamental theorem of calculus, this is a minus. Once you distribute the minus to a plus, you get a minus. So this is your final answer. All right. And then the one on the right, that is also an exponential function. So we have to bring up a very important formula for that one. So that is the integral of a base, the b is the base, and then b is a real number, 2, 5, 6, 10, 1,000, whatever you like. The variable is in the exponent. This is an exponential function. So how do you deal with this kind of integral? So that is equals to b to the x itself divided by ln b. This is another formula that you will have to take away in this lesson. All right, got that? So back to my problem. So the base is equals to 2. So that is equals to 2 to the x divided by ln2, such that x goes from 0 to 4. Plug in the 4, plug in the 0, the job is done. So 2 to the 4th divided by ln2, and then minus 2 to the 0 divided by ln2. So this is 16 divided by ln2 minus 2 to the 0 power is not 0, right? That is 1 divided by ln2. So you can take this as the final answer, or you can do 16 minus 1, which is 15. 16 minus 1, let me just write 15. So 15, and then ln2, because ln2 is a common denominator. So either one is fine. All right, so that is the end of this video. Please don't forget to put this formula down on your notebook. Make it big somewhere you can see easily. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help and support. I will see you all in the next lesson. Signing out for now.